Hello class and welcome to section 7.6. Today we're going to go ahead and look at rational exponents. So remember, rational or ratio is another way to talk about fractions. Okay, so it's when we have fractional exponents. That's what we're looking at today. So the first one we want to look at is how could we simplify b to the 1/2 to the second? So there's two ways we can think about this. I could think, well, it's b to the 1/2 and a power to a power, you multiply those two. Okay, so it's 1/2 times 2. Well, 1/2 times 2 is 1, so it's b to the first, or just b. That's one way we can think about it. Another way you could think about it is since it's b to the 1/2 to the second, it's really b to the 1/2 times b to the 1/2. And remember, now when we multiply, we add exponents, so it's b to the 1/2 plus 1/2. Well, 1/2 plus 1/2 is 1, so it's b to the first, which also equals b. Okay, so there's two different ways we can think about it. Whichever way you would like to is totally up to you. So we're going to look at how we can write rational exponents. One thing that I would like to point out is that if I have b to the 1/2, that's the same as saying, well, it's the square root of b. Okay, so you can rewrite these in other ways. So we're also going to look at how to rewrite fractional exponents today. So, for instance, for any real positive number b and for any positive integer n, b to the 1 over n is equal to, really what it is it's the nth root of b. Okay, so that's our first example. One that I will point out is we just looked at b to the 1/2. This is the same as the square root of b. We don't typically write the 2 there. That's the only case where we don't write the 2. Okay, so something to keep in mind. All right, so we're going to go ahead. We need to evaluate 8 to the 1/3 power. Well, it's like my b is the 8. Okay, so they're the same, so it's 8. And then it's going to be, well, my n is 3. So it's the third root of 8, or the cubed root of 8. And so what it's saying is, what number 3 times multiplies to 8? Maybe you don't remember. So you can do it on your calculator. On the TI-84, you would go math. And does everybody see number 4? It says the cubed root right there on number 4. So I would go to 4, and the cubed root of 8, okay, is 2. Both the cubed root is on the scientific graphing calculator and the Inspire. So if you need help with those, just let me know and I can help you find them. So this is equal to 2. Okay, let's go ahead and look at a few more. We want to write it in radical form. Well, my n in this case is 4, so it's the 4th root of my b is a. My next example is x to the 1/5. Well, the n part is 5, so it's the 5th root of x. So there it is in radical form. Remember that the square root, this is the radical, so this is keeping it in radical form. Now we're going to go ahead and go the opposite way. I'm going to give you radical form and I want you to put it in exponential form. So to go to exponential, it would be that y to the 1 over, well, what's this? 1 over 3. So there it is in exponential form. Example 4 says evaluate 16 to the negative 1/4. Okay, well, let's evaluate this. Before we need to take care of our negative exponent. Whenever you have a negative exponent, remember you can move it to the denominator and it will become positive, so it's 1 over 16 to the 1/4 power. So this is equal to 1 over, now it's 4, then the square root of 16. So it's the 4th root of 16. So on your calculator, there is a button that you would use for this, and it's probably looks like it's going to be the x and then the radical sign. So in this case, you would type in 4, then you'd find this button on your calculator, and 16. Or maybe you know what number multiplied together 4 times gives you 16. But if you don't, you can use your calculator. So in my case, I would be 4. I would go to math. And then if you look at number 5 here, it's the x root, so 5. And then I would type in 16. And that will give me 2, because 2 times 2 times 2 times 2 gives me 16. So it's really 1 over 2. So there's my answer for number 4. Okay, so now we're going to go ahead and take a look at what we looked at earlier today. We have 8 to the 1/3 power. Well, remember we can rewrite this. as the cubed root of 8. And one thing I would notice, there's a 1 still here. It's really 8 to the first power, but we don't write it. So now we're going to look at, well, what if I have the 2/3 power? Well, I can rewrite it the same way. What's in the n is the 3, so it's the cubed root of 8. But now it's really 8 to the second power. Okay, so that's one way you can look at it. Or the other way you could look at it is it's the cubed root of 8, okay, all of that to the second. Either way is fine. This one might be a little bit easier because the cubed root of 8 we found out earlier was 2, and then 2 squared would give me 4. So there would be my answer for that. So in general, for any fraction exponent, m over n, okay, so for any non-zero real number b and any integers m and n with n greater than 1, we are going to go ahead and write it as the nth root of b to the m. Or, like I said, you could rewrite it as the nth root of b all to the m power. Either way is perfectly fine. Okay. So let's go ahead and look at example 5. We want to evaluate this. Okay. So it's the 5th root of 243, all, take that, to the 3rd power. Okay. Well, on your calculator, if you do the 5th root, so it's the 5th, and then I go math. Make sure you can do this on your calculator. The 5th root of 243, that will give me 3. Okay, so this inside part gives me 3. So it's really 3 to the 3rd, which we know 3 to the 3rd is 27. So there is my answer for example 5. Example 6. We want to go ahead and write this in exponential form. So we have y to the 4 over 6. And whenever you can, you should reduce. So we have 4 over 6. Well, they're both divisible by 2, so I would have 2 over 3. So it's y to the 2/3 power. So there it is, simplified all the way. Some things just to recap and remember. That t, or in this case right here, y, would be the base. Okay. In this case, 3 is the power, right? Because it's to that power. So if I look at my example here, it was to the 4th power. So that's what's in the top of the fraction. And then what's in the denominator is the index. Okay, so or like the nth root. So this is the 6th root. This is the 4th root. So it's the index is also another term for it. Okay. All right, let's go ahead and look at example 7. The radius of a sphere with a given volume is given by r equals, and it's 3v over 4 pi all to the 1/3 power. Find the radius of a ball whose volume is 77 centimeters cubed. Okay, so the volume is, so this is v equals 77. So I'm going to plug that in. So r equals 3 times my volume, 77, all over 4 pi to the 1/3 power. Okay, so I would go ahead and figure out, well, what is 3 times 77? 3 times 77 is 231 all over 4 pi. And that's all being taken to the 1/3 power. And now all you have to do is use your calculator. Okay, remember the 1/3 power is the same as the cubed root. So now I can type this into my calculator. I'm going to do the cubed root. So I go to math. The cubed root is number 4. The cubed root of 231 being divided by, now here's where you need to be careful. It's 4 times pi, so you have to put that in parentheses because it's more than one thing. So 4 pi, end the parentheses, and hit enter. And you get that the radius is 2.639. Okay. So making sure you can do this on your calculator is important, so I hope everyone is doing this while on their calculator as well. So we get 2.639, and I would label this as the radius. Okay, well, if the volume centimeters cubed, radius is just centimeters. Okay, there is example 7. All right, Some properties of exponents that we want to make sure that we remember. The product of powers. Okay, so product of powers. Remember, when you're multiplying monomials, you add their exponents. Okay, so on your little box, you should have some room off to the product of powers property to write add exponents. Okay, so example 8. Okay, it's written off to the side there. We would add these. So it's going to be 2 plus 3 plus 4. Well, 2 plus 3 is 5. 5 plus 4 is 9. So this is x to the 9th. Example 10. Sorry, example 9. We would have x to the 1/5 times x to the 7/5. So I would add those. When the denominators are the same, I would just take 1 plus 7, which gives me x to the 8 over 5, and I cannot simplify that at all, so it's to the 8/5. Okay, my next rule to remember is the power of powers. So remember with this, you are going to multiply the exponents. Okay, so multiply. So when it's a power of powers, you multiply. So you would take 2 times 4, which gives me y to the 8th. So we have y to the 8th. Now you go ahead, really quickly, try the next example. If you need to, pause it and give it a try. Remember, each piece is going to get that cubed root. So it would be 8 to the 1/3 power, and then I would have 2 times 1/3 is going to give me x, so 2/3, and then I'm going to have y to the 1/3. And we would write this, the cubed root of 8 is 2, x to 2/3, y to the 1/3. So here's my answer for example 11. Example 12 and 13, use the quotient of powers. So remember, quotient of powers, when you're dividing, you subtract exponents. So we would have 5 minus 11, which will give me -6. Okay, so I would rewrite this as 1 over m to the 6th. The other way you could think about it is you always bring the smaller exponent to the larger exponent, and then you subtract. So if I would take and bring the 5 down here and subtract 11 minus 5 is same thing. Okay, example 13. We have the 8th root of 81. So I can write this as 81 to the 1/8 power, and this is really 3 to the 1/6 power. The trick here is rewriting it. See how this one is a base 3 and this one isn't? I would try and figure out, well, 3 to what power gives me 81? I know 3 to the 3rd is 27, so I would try on my calculator 3 to the 4th. 3 to the 4th gives me 81, so I'm going to rewrite 81 as 3 to the 4th. Okay, so I would have that this is 3 to the 4th to the 1/8 over 3 to the 1/6. Now remember, power to power, we just did this rule. We would multiply 4 times 1/8. So I'd have 4 over 8, so it's really 3 to the 1/2 over 3 to the 1/6. Okay, it was important that I changed that 81 into a base 3 so that now they're the same bases, so now I can go ahead and subtract them. So what I'm going to have is 3 to the 1/2 minus 1/6. I would get a common denominator, so I would have to multiply this one, so it would be 3 to the 3 over 6 minus 1 over 6, which would give me 3 to the 2/6. And this simplifies 2 over 6 reduces to 3 to the 1/3. So I could leave it written like that, or I could also write it as the cubed root of 3. Either answer would be good. Okay. And one last rule that we're going to go ahead and look at. Negative exponents, just a reminder, you cannot leave negative exponents in the final answer. To get rid of a negative exponent, you move it to the inverse side of the fraction and make the exponent positive. So here, when it's talking about this inverse side, what it's really talking about, if you're in the numerator, go to the denominator. If you're on the denominator, move it to the numerator to make it positive. Okay, so my 3 here, it's really to a positive 1 power, so it's going to stay in the numerator. But this a to the negative fifth, it's negative, so if I move it to the denominator, it becomes positive. So I have 3 over a to the fifth. All right, and example 15. This one I have 1 over r to the negative 4/5. So in order to make it positive, I would move it up to the numerator. So I would have r to the 4/5 power. And that would be example 15. So we don't have simplified, so we don't have negative exponents. Okay. Some rules to live by. Okay, when you're solving or simplifying, you can never have a 0. Can't spell. There we go. 0. A radical. Nor a fractional exponent. On the bottom of a fraction. Okay, so remember radical is that square root sign, or a fractional exponent. Okay, can't have those in the bottom of a fraction. So let's go ahead and look at some examples where we can simplify. Example 16. We want to simplify this. So it's the cubed root of 16x to the fourth. So what I have to think is, okay, 16. You can't take the perfect cube of that. If I do it on my calculator, it will give me a decimal. So I would think, well, is there something that multiplies to 16 that you can take the cubed root of? I know 8, I can take the cubed root of that. 8 times 2 is 16. And now I have x to the fourth, okay? 4 is not evenly divisible by 3, so I'm going to rewrite it so it is. So it's going to be x to the third times x. Okay, I just kind of did some simplifying, breaking down. So if I check, 8 times 2 still gives me 16. X to the third times x still gives me x to the fourth. Now I go ahead and I say, well, what's the cubed root of 8? The cubed root of 8 is 2, because 2 times 2 times 2 is 8. And the cubed root of 2, I cannot do the cubed root of 2, so I'm going to leave it underneath the radical. And x to the third, all you have to do is take 3 divided by 3, that gives you x to the first. And x to the first is not evenly divisible, so I leave it under the radical. So to write this a little nicer, it would be 2x, then the cubed root of 2x. Example 17. Okay, we want to simplify this. First thing that I would do is rewrite it with fractions. So it's really 2 to the 1/3 power over 2 to the 1/4. My bases are both 2, so I can go ahead and actually say, well, it's 2 to the 1/3 minus 1/4. Now I would get a common denominator, so it's going to be 2 to the 4 over 12 minus 3 over 12. Now if the denominators are the same, it's going to be 2 to the 1/12. You can write it like 2 to the 1/12, or you can write it as the 12th root of 2. So there's example 17 simplified. If you have any questions on 17 or 16, please make sure you write them down and ask me tomorrow when you get to class. Let's go ahead and look at example 18. Okay, we want to go ahead and simplify. So let's go ahead and just look at our numerators first. Okay, these are being multiplied, so I would add exponents. So it's going to be 4 plus 2, which gives me 6. So it's x to the 6 over 3, all over x to the 1/3. 6 over 3 is going to give me 2, so I have x to the second. Maybe it'd be easier, though, to leave it as x to the 6 over 3. And the reason I said that is because I'm going to subtract these. So I have 1/3. So I would have 6 over 3 minus 1/3. So 6 minus 1 is 5/3. So I have x to the 5/3. And I can write it like this, or I could put it into a radical form. It's going to be the cubed root of x to the 5th. Either one of those answers is perfectly fine. Okay. And our last problem, number 19. So we want to simplify this. So my numerator again, it's y times y squared, so it's really y to the first. 1 plus 2 is 3, so I have y to the third, all over y to the 1/2. My bases are both y, so I can go ahead and subtract. So it's y to the third minus 1/2. Okay. I'm going to go ahead and get a common denominator. So it'd be 2. So I would have 6 over 2 minus 1 over 2. 6 minus 1 is 5, so it's 5 over 2. And I could write this as I can write it as y to the 5 over 2, or I can write it as the square root of y to the 5th. And remember, when it's the square root, we usually don't write the 2, so it's going to look like this. Okay. All right, so that will be it for section 7.6 today. If you have any questions, please write them down. Let me know. Otherwise, I will see you, and have a great day.